a little over 4 years now. Most recently, I was a member of the GSS team in Red Hat. I was in the Kernel team there. And I'm going to share some of the stuff I learned. So basically what we're going to go over is how you can tune your kernel and which tunings work for. I'm going to give a few example workloads, for instance, a virtualization host, database workloads, things of that nature. And things you can tune are I/O schedulers, how your memory management works, all that sort of thing. So first, your proxys file system. That's where you can go to tune most of your kernel parameters. So you can both read and set kernel tunings. For instance, that's still plugging in. However, everything you set there will be lost as soon as you reboot the computer. There we go. And as you see here, we have different folders. This is a virtual file system. You can, like I said, you can read settings here. You can change them. And I'll go over what dirty background ratio is here shortly. You also have your /etsy/sysctl.com. And as you can see, this is a fresh VM I just installed this morning, so. Anyway, any setting you have in your Etsy sysctl.com can be changed by manually changing settings in your proxys file system. Anything you put there is non-volatile, so it will survive reboots. And you can make changes to the file on the fly and then implement them by running sysctl-p. So for instance, so you'll notice it's still what I set it to earlier. And now it's changed it to the new setting. Okay, we're going to talk a little bit about huge pages. Huge pages are, so when you have your translations look-aside buffer, which is where the processor stores the current page cache. Not page cache, sorry, brain burn. It stores which bits of memory are being accessed currently, and these are known as pages. Most of your pages are 4 kilobytes in size in Intel systems. Huge pages are 2 megabytes. So you can see that I guess that's a VM.
I'm sorry, Can you please make the font a little bit bigger in the terminal? Yeah.
There we go. For instance, you see here the huge page size, 2048 kilobytes, 4 megabytes. The downside of using huge pages is that you can increase your page faults, because if you're in a page, you're using memory that's in the page, a huge page, and your program is not properly aligned to the huge page borders, you can wind up needing memory in the next page and it's not loaded into the CPU cache. But the benefit is you can massively speed up your memory usage. Listening. Another thing about huge pages is, oh crap, I need to have that graph. I apologize, y'all. I'm having a brain fart here. All right, so anyway, the advantages of using huge pages is that by having larger chunks of contiguous memory being pulled into cache at once, you wind up not needing to actually do as much paging, so this can reduce CPU load. Like I said though, you might wind up overrunning your memory boundaries there, and so you'll wind up, on a certain application loads, you might wind up actually causing problems with page faults because of not aligned memory and all that. In newer kernels, you have transparent huge pages, which and the idea is that the kernel will automatically do your huge pages for you, whereas traditional huge pages must be manually set, and it requires some calculation because anything that you set manually with huge pages becomes unavailable for system memory for things like cache and for any program that cannot use huge pages. There's a lot of software out there, and a lot of your desktop applications, for instance, are not configured to use huge pages. However, memory-intensive loads such as databases, virtual machines, QEMU, for instance, can use huge pages, and in fact, they will run more efficiently if you do so. If you set up traditional huge pages, you'll need to also modify your csecuritylimits.conf, and you'll basically need to replace the user, where it says user there, you'll have to put in the username that's actually running the program. For instance, if you're running an Oracle database, you'd probably be running it under the Oracle username. And then you put in hard memlock, and then X is the amount of memory that is actually occupied by the huge pages. IO schedulers, the default for most Linuxes is completely fair queue, which is basically as IO requests come in, they get put into a queue and they get allotted a certain amount of time, and everything gets allotted a fair amount of time, the same amount of time. Deadline scheduler, everything is guaranteed to start by a certain point, and this, by the way, is disk IO. No op is basically there's no attempt to actually modify the scheduling of disk I/O at all. It goes straight to, it comes in, and basically it's first in, first out type situation. This has an advantage in applications such as if you're a guest in a virtualized environment, you want to let the hypervisor handle your disk I/O rather than trying to do it yourself. So you're in virtual machines, you'll want to set the no-op scheduler. In Fedora, you'll want to go into your back. So go into your etc default, and at the end of your command line, your kernel command line, you would add and that's how you change your scheduler. You could do like I said, the completely fair queue is the default, and so therefore you don't actually have to set it here on your command line. Oh, actually, you know what?
Check your spelling. Right.
Oh, I can't spell. And then you're on.
There's a dash.
And then once you edit your etc default grub file, you run grub to make config, and it recreates your grub config in /boot. And then you reboot. And while that's going. So basically you choose your I/O scheduler based on your workload. For instance, if you're doing heavily disk-bound activity, then it's been shown that the deadline scheduler helps improve your throughput, whereas completely fair queue is good for most generic loads. No-op is good for virtualized guests, because you'll want your host operating system or your hypervisor to actually do your disk scheduling for you. Another thing you'll want to consider in kernel tuning is your swap usage. In some applications, for instance, if you're running an NFS server, it doesn't so much matter if you're swapping unused pages out to disk. And in fact, that actually help free up memory for disk cache and for things that are getting accessed more often. So in an NFS server, it might be desirable to have a higher swap setting. But if you have a memory-intensive application, such as a database, for instance, MySQL or MariaDB, you'll want to have your very low swap utilization, because otherwise you'll wind up using your disk in place of RAM, and your system will bog down on disk I/O. And there's a good chance that this will eventually lead to your system either hanging or crashing outright. Things like virtual machines, in my testing, using a Linux host with KVM, swapping doesn't really seem to make much difference in whether the system is performing better or not. So that, once again, is largely dependent on your workloads in your guests, and so that's something you'll want to tune based on them. For most of the time, leaving the default swap is fine. And for setting your swap, that's really this thing. And so your swappiness setting ranges from 0 to 100, and this is how likely your system is to swap. If you set it to 0, it's not going to swap at all unless you're starting to run out of RAM. If you set it to 100, you're probably going to be swapping most of the time. The default setting is 60, and like I said, that works well for most workloads. If you're running a database, you'll probably want to set it to around 10. If you're running, say, an Apache web server, leaving it at the default is fine. NFS, leaving it at default is fine. So anyway, you set it here. You know, like I said, default is 60. Then I run sysctl to make my change take effect. I'll go ahead and run over some examples. For instance, with a KVM host, database, Java, and web server. If you're using a Linux box, say Fedora, as a KVM host, you'll probably want to go with a deadline IO scheduler because it can get intensive on your disk load. This is one of those things that some testing may be required. You'll want to check between deadline and CFQ for your host to see which one gives you better performance. I've found that with some guest workloads, CFQ does give better performance, but most of the time, deadline is the way to go. You'll want to go ahead and set probably around 60 to 70% of your available RAM up as huge pages. So if you have, say, 12 gigabytes, you'll want to figure out how many huge pages you can fit in 12 gigabytes. Saying basically, and once again, that's dependent on your huge page size, and that varies from system to system. Most Intel systems, it will be 2048 kilobytes. And then you want to go ahead and do a verse edit on your VM and add those 3 lines right there. And then you'll need to reboot your VM in order for the changes to take effect. And most of the time, like I said, testing has shown that a lot of times setting your swappiness to pretty low will increase your system performance, but there are times when leaving it at the default will be just fine. That's something you'll want to test. And a lot of times you'll want to set your VM.min free kbytes to a higher value than the default. And by doing that, that frees up space for any kind of incoming network traffic that you might be having. So that way you'll have memory immediately available for incoming packets and such like. Once again, this is one of those things that you'll want to test. If you're getting, you can sometimes be getting errors because you'll receive network packets faster than you can clear out cache to actually handle them. And in those instances, that's when you'll be wanting to increase your min-free kbytes. You'll want to probably keep the maximum around 1 gigabyte, because that way you'll not be overrunning your CPU with constantly clearing out cache. Any more than 1 gigabyte is going to be to overrun, or plenty anyway. If you're running a database load, once again, you'll definitely want to use the deadline scheduler. If you're running a Oracle DB, you can get your DB admin to get your SGA and PGA, and then you can calculate out the number of huge pages you'll want to use. Huge pages help greatly with databases that thrash your memory, because by using the larger page size, you don't have to do as much paging as you would otherwise. And then accordingly, you'll want to set your security limits.conf. You'll want to set your swappiness down to 10, because otherwise you'll start thrashing your disk when you get high loads on your database. This can cause your system once again to bog down and possibly even crash. You'll want to set several dirty page tunables. For instance, the previously mentioned dirty background ratio is one. Actually, bang. So you'll want to set your dirty background ratio, your dirty expire syntax, dirty writeback syntax, and I'll go ahead and show you right quick where you want to set them. The dirty background ratio you want to set to probably about 15, so that means that once 15% of your pages are ready to be written to disk, they will do so. And these are all settings that control how often pages that need to be written to disk get written to disk. Dirty expire syntax is how often you'll automatically start writing stuff to disk, and as well as dirty writeback. And let's see. And also, you'll need to probably set your shared memory, your shared max and small, and so on and so forth. And this is done according to your database vendor's instructions. Every database vendor has you set them in slightly different ways, and depending on the amount of RAM your system has and how much your database is expected to use. With NFS, you'll want to go with your completely fair scheduler. Mostly you'll want to use your defaults. If you're getting a lot of overruns in your incoming and outgoing packets, you might want to set your min-free kbytes to free up some RAM to handle those packets. once again, if you're actually running your NFS server in a VM, I don't know why you would, but if you'd still probably want to go with a no-op for that. If you're running a large Java application, you might want to consider deadline, you might want to consider CFQ. It depends on how much you're actually accessing the disk. If you're not accessing the disk very much, then you'll probably just might as well stay with CFQ. You'll want to set up huge pages. In your Java command line, you'll do, at least for OpenJDK and Oracle in Java, you'll want to use the -XX plus use large pages option. And that will tell it to actually use huge pages. And you'll need to include enough memory for your heap, plus enough memory for your JVM, and any threads that all the extra threads you might have running. So that can take a little bit of math to figure out. Basically, a good rule of thumb is heap plus about probably about 500 megabytes is a good rule of thumb for your Java application. The more Java threads you have, obviously, the more you'll need to increase that. And then, of course, you'll need to set your etsy-security-limits.conf appropriately so that your Java application can actually use the huge pages. And you'll need to set shared memory, for instance, and max. And that must be at least the size of your largest heap for any Java processes that you have going. If you're running a web server, CFQ is a good way to go. You'll want to set your dirty page tunables about the same as you would for a database to help clear out caches and on a deterministic level. That way you can also set your min-free kbytes because you'll to handle the network traffic that you have incoming. And that's basically to compensate, so if you write your dirty pages to disk more often, that your CPU will have to do less work to actually maintain that minimum free memory. And that way you'll have your memory available for incoming packets. And this, once again, reduces buffer overrun. So y'all have any questions?
Well, you are mostly lowering the swappiness, and what would be an example of application that actually requires, or well, it would be better to use swappiness closer to 100?
I actually have not encountered an application that actually requires it. Oracle recommends that you set your swappiness to 100 because they believe that it means that everything other than Oracle DB will be swapped out. And yes, this is in Oracle's documentation for their database.
You take it all around.
So, and this leads to many people that are running Oracle DB then having issues with their systems hanging because they're basically using their disk as RAM.
Okay, thanks.
Any other questions?
You mentioned for web servers. Hi. So you had a slide about web servers. So are there any other recommendations for highly concurrent networking applications?
Once again, you want to make sure you have some free RAM available to prevent buffer overrun, because if you have a lot of network traffic coming in over your NICs, they might not have enough RAM available on the NIC itself, and what will happen is if you have a lot of cache in RAM, then oftentimes you'll network traffic on a high speed, like say 10 gig NIC, you might actually have more network traffic coming in faster than your CPU can actually clear out pages for that incoming network traffic. So that's why it's a good idea to make sure you have a minimum buffer available for it, so that it's immediately writable for incoming traffic.
I just have something to add. There is a little piece of software called Dulaney. Sorry, I just have a little bit something to add. There is a little piece of software called Dulaney, which provides some, basically those samples you have given plus some others, which can be used as a kind of template for all those tunings, and you can switch between those different profiles with tune the IEM set and then the profile name.
So the problem with TuneD, and while the profiles that it has are pretty good defaults for various workloads, and in fact, for most of the time I find that the profiles in TuneD are excellent defaults. The problem is if you have issues with, say, a server and TuneD is running, sometimes you go to set something in your etc sysdetail.conf or your proc.sys file system, and TuneD overrides it, and this can make troubleshooting issues difficult. So while TuneD works very well, I don't actually recommend running it directly because of the troubleshooting issues it can cause.
Well, it needs to be documented, of course.
Of course.
What about ZRAM? Have you ever used ZRAM?
I have not.
Because we have started it using in Anaconda recently, and we use it as a swap device. So we create a ZRAM device that is as big as RAM, and we use it as a swap device, so all RAM Anaconda uses is automatically compressed, and it gives quite nice results, like the compression ratio is around 50%. So
the problem there is, if you're in a high performance, memory intensive application, then the overhead of decompressing and recompressing can cause you latency issues. I mean, if you have a database that's getting a couple million queries a second, by having to compress and decompress, your latency is going to go through the roof. So that would be my problem with that, if that makes sense.
So you have to be careful when using DRAM too, because the way it works is, it compresses the pages, and it's awesome to save time. But if your machine actually approaches the point where it actually has to start swapping stuff out, in order to do that, it actually has to uncompress the page and then write it out to swap. So it takes even longer when you get into that really, really low memory situation.
But our situation is that, like, if it wants to start to swap, it can't, because there is no swap yet. So
that's right. In Anaconda, you would run into that. But I mean, in general usage, is something to be aware of, because people think it's awesome, and I can take this workload that runs out of memory and gets OOM killers, and just add ZRAM, and it'll magically make everything better. And it will to a point. But if your workload is that much massively over what your machine can handle, it's going to make things worse in the long run. So
yeah, you're better off adding RAM at that point.
Yeah. But for Anaconda, as long as it doesn't break things, it's probably actually helpful. But it could break things.
But once you have the system installed, I mean, on a desktop, what do you think? I would say on a desktop might be helpful, but on a server, I would not recommend it.
Actually, it's almost the opposite is true. If you're running an Oracle server, you've probably got, here's the memory that I'm allocating, right? And Oracle won't grab anything more than that. If you're running, for a lot of server workloads, you know exactly what it is. So you can turn on ZRAM and it would probably be helpful, but you're not going to go wild. If you're on a desktop and you're using a browser that, you know, Facebook's going to grab a gig for its page and all this, you end up going over it, and all of a sudden everything is going fine because you're not using too much memory, and all of a sudden, oops.
The issue is
space and it's going to slow everything down.
The issue with running it on the server in the server environment is the latency that it causes as you compress and decompress. That's adding extra.
It is, but if your choices that are swapped, it may end up working out better for you. I'm just saying, you know your memory workload in a server more than you do in a desktop. It's much more dynamic in a desktop.
Yeah, we use it, for example, on our KVM host. So there is a choice between ZRAM or actual swap, and it's much faster. And you can create as many ZRAM devices as you have CPUs. So the compression and decompression is running in parallel. So it's really fast. We actually haven't seen any like drop in performance. It's definitely much better than using the actual swap that is in the PC.
It's a good point. It might be something you consider also on ARM devices. For instance, if you're running on an SD card.
Oh yeah, exactly.
Any other questions?
Do you ever see any recommendations for Linux hosts that are used for networking devices, say OpenStack, Neutron, or something that needs to be low latent? Is that a recommendation you guys would give, like a very low swapness rating, or is that generally not that important?
If it's just network intensive, then you can probably leave it at the default swappiness of 60. It depends on what other workloads you might have on the device. If it's like, and then with OpenStack, because for instance you have your storage, you'll definitely want to leave your swappiness set to the default, because that's essentially an NFS server for all intents and purposes. But for instance, on your hypervisors, you might need to set it lower depending on your actual guest workload. And this is something that you'll probably want to play with to see which gives you the best results. Start out at 60, see how it performs, drop it down to say 10 or 20, see how it performs, and if it does better, then obviously leave it. If it doesn't, then change it back. But I found that when you're having a hypervisor, the swappiness is largely dependent on what your guest workload is. Anything other questions? Thank you all for coming.